Hello everyone, in this video I will tell you why I believe that battery electric combine harvesters make no sense. What you can see here is a 1972 Claas Mercator combine harvester, which by today's standards is a fairly small and largely obsolete combine. I'm choosing this old class because it has a Perkins 6 354 cubic inch engine which is rated 78 kilowatts. This is not a lot of power for a combine harvester, and it is less than what most modern saloons have underneath their bonnets. Electric motors are highly efficient and power outputs in the 80 kilowatt range are easily possible, so in theory, at least small electric combine harvesters should be technically feasible. But why aren't we seeing them already as we do with passenger cars? That is because battery electric powertrains are not at all suited for combine harvesters. Passenger cars have motors with high power output figures. Approximately 100 kilowatts is the typical minimum in most normal saloons, but the truth is that with normal driving speeds of, let's say, 100 kilometers per hour, cars typically only need 25 kilowatts or even less. So most of the engine power in cars is not needed, which is why electric motors work so well in cars. Combine harvesters, however, combine harvesting and threshing, which is a process that requires a lot of power. The Claas Mercator actually needs all of its engine 78 kilowatts. And there's a reason why some farmers decided to install even more powerful engines on their Mercators. What this means is that the engine load is much higher than in passenger cars, and a heavy-duty engine is definitely needed for a combine harvester. Electric motors can handle this, but their efficiency is not 100%. Good electric motors can convert up to 99% of the electrical energy into mechanical work. But that means that in case of a 78 kilowatt engine, that it produces 790 watts of heat power, which need to be disposed of. So a proper cooling system is needed. Now imagine the cooling system needed for a 400 kilowatt motor that only has 95% efficiency. Yes, that is 21 kilowatts. So electric combine harvesters definitely have to keep the annoying cooler, though I have to say that the cooler would be smaller than a cooler for a diesel engine of the same power output. The cooler, though, is just a minor problem that can be solved rather easily. A much bigger problem would be the electrical energy that can be stored by the secondary cells. If a combine harvester with a 78 kilowatt motor is used for 12 hours per day, it requires 936 kilowatt hours of energy. With a motor efficiency of 99%, this becomes 945 kilowatt hours, and if we consider a battery buffer, we need secondary cells with a combined energy storage capacity of at least 1 megawatt hour for a small combine harvester such as the Claas Mercator. Such a large battery would have a mass of around 5,500 to 6,000 kilograms, and it would cost around 100,000 euros if we used 2020 lithium-ion secondary cell technology. The Claas Mercator has a maximum permissible vehicle mass of 7,400 kilograms, and that includes 3,000 cubic decimeters of harvested grain, which in case of barley weigh around 1,800 kilograms. So we can easily see that making an electric combine harvester with the Claas Mercator's threshing capacity would require designing a much bigger and heavier combine than the Mercator is. This would also add so much to the drag induced by the vehicle weight that the combine would need approximately 10 extra kilowatts just for moving around its battery at a working speed of 2 meters per second if the tire's drag coefficient was 0.08 on dry soil. Soil also can't be indefinitely compressed by vehicle weight, so a large 300 or even 400 kilowatt combine would require giant crawler tracks in order to distribute its massive battery weight across the ground, which would increase vehicle development and manufacturing cost. Diesel engines are way less efficient at converting their input energy into mechanical work than electric motors, with diesel efficiency typically being in the low 40% range. But petroleum distilled diesel engine fuel holds 12 kilowatt hours of energy per kilogram, which is a much higher energy density than a lithium ion secondary cell. So a 200 kilogram diesel fuel tank would be sufficient in this class example. Summing this up, with current battery technology, a battery electric combine harvester would be too expensive due to additional design and manufacturing cost, as well as sheer battery cost. In addition to that, I believe that the combine would become very impractical. I mean, a Mercator at the size of election. But that's it for this video. I hope that you learned something interesting today, and I will see you in the next video.